Kia ora everybody, welcome back to week 2. This week we're going to look at the muscular and skeletal system. We're going to kick it off with the skeletal system. By the end you should be able to list the functions of the skeletal system, name 4 main classifications of bone based on their shape, identify the subdivisions of the skeleton as either axial or appendicular, label common bones of the skeleton, and describe anatomical direction. So our skeleton is the internal frame of the body, and it includes bones, cartilages, and joints. In addition to providing structure, bones articulate or come together at joints to allow our bodies to move. The skeleton is essential for protecting organs, producing blood cells, storing essential minerals, and anchoring skeletal muscles so that when they contract, they cause movements. If we break that previous slide down into functions, we've got 5 main functions to remember: framework, protection, attachment, production, and storage. Other than dentin in your teeth, bone is the hardest structure of the body. It's classified as an organ because it's composed of mostly connective and epithelial tissue. It has bone cells, it has marrow and blood vessels. It's also a mineral storage of calcium carbonate and calcium phosphate. Here is a diagram of a classic long bone structure. So you'll need to be able to lay all this on a diagram. At the ends of a long bone you have the epiphysis. Proximal means closer to the point of rotation on that bone. Distal means further away. So if you talk about the humerus of the arm, distal would be the end of the humerus that is closest to the hand, whereas the proximal epiphysis would be the end that is closest to the shoulder. The diaphysis is the space in between. You have the medullary cavity, which is the space inside the bone where you will see yellow bone marrow. Yellow bone marrow is fat storage, so it's storage of energy. In the epiphysis, you have spongy bone, which is the site of red bone marrow, where our blood cells are produced. Long bone is made up of either spongy bone or compact bone, which is squashed together, and it's surrounded in like a clear type connective tissue called periosteum. If we look at classifying bones, we can do that based on their shape. It's quite simple. The name of the shape describes what the bone looks like. So, for example, a humerus, again, of the arm is a long bone because it's longer than it is wide. Then we have short bones, such as the short cuboidal shaped bones in your wrist and in your ankles. Then we have flat bones, such as your sternum is a flat bone, your scapula on the back is a flat bone, a good space for muscle attachment and protecting organs internally. And then an irregular bone is a funny shaped bone that pretty much, if it's not long, if it's not short, and it's not flat, then it's an irregular bone. The individual vertebrae of your spine are good examples of irregular shaped bones. So this slide is about how our bones grow and how they remodeled, which happens consistently from fetal development through to childhood development until adult development, and continuing on right through your adult life. It's affected by genetics, so you can't choose your parents, so your genetics determines bone growth and remodeling, nutrition, so what you consume, and mechanical stresses such as putting load through bones. Ossification is the process of bone formation by osteocytes, so our bone cells. This begins during fetal development, continues right through to adulthood. We've got 3 bone cells. You'll need to know what each of these do, and it's in the self-directed task this week. Osteoclasts, think class C, crush, so they're our bone breaking cells. And then osteoblasts, think blasts is such a B, they build bone. And then our osteocytes are mature osteoblasts that have built a whole lot of bone marrow into the matrix of a bone. Once they've finished their job, they become fixed in that space and then coordinate bone remodeling from there on in. Here is a diagram of what happens during growth of a long bone in an unborn child. So we've got in an embryo through to a fetal development and then into a child who's been born. Initially, that bone starts off mostly as that blue stuff, which is hyaline cartilage. Bone starts to be laid down by our osteoblasts, forming a bone collar, and you'll get some bone in the middle, and that's the point that sort of growth and remodeling starts to happen. So as bone is laid down, hyaline cartilage grows on the ends, and that pushes lengthwise growth in long bone, but also width growth, which is called appositional growth. Our osteoclasts, which break down bone, start to resorb, which is the term used for breaking down bone on the inside of the long bone, creating that medullary cavity. Bone collar gets wider. Osteoclasts take away bone on the inside. Bone is laid down on the lengthwise end. You've got bone growing in the epiphyses. And you'll see that the hyaline cartilage is beginning to be completely replaced. By the time a child is born, a full long bone is formed. You have hyaline cartilage or articular cartilage on the ends of those long bones, and then you have the epiphyseal plate, which is also soft cartilage. As a child grows and bones get longer, hyaline cartilage is laid on top of that epiphyseal plate while bone starts to grow underneath, and that creates this lengthwise growth in bone. By the time you become mature and stop growing in height, that epiphyseal plate will calcify or harden and become complete bone. And I believe that you can palpate or massage areas of long bones to feel if that epiphyseal plate is still soft or if it's hard. And if it's hard, I'm afraid you've stopped growing. Here's just another diagram explaining that process of lengthwise growth, where cartilage grows, replaced by bone, and how as bone gets longer, areas are resorbed by the osteoclasts, and how bone is rebuilt to make bone long and wide. Appositional growth is widthwise growth. Resorption is the term used to describe breaking down bone or removing it. So it's a constant cycle of bone building and bone resorption happening at the same time, so that bone material is continually being replaced and built, depending on things like your genetics, nutrition, mechanical stresses, those kinds of things. Another component of this week is learning the skeleton. There are 206 bones, and I like to start by classifying the skeleton into two different sections. So when you're learning the bones of the skeleton, if you can just start with being able to label the axial skeleton and the appendicular skeleton separately, breaks it down into small chunks. So the axial skeleton is the skeleton that makes up the longitudinal axis of the skeleton. So that includes the skull, the mandible is the jaw, the sternum, the vertebral column, your ribs, your sacrum, and your coccyx. So the full longitudinal axis of the body. But it does not include the bones that attach your limbs to the axial skeleton. So it doesn't include your clavicle, it doesn't include your scapula, and it doesn't include the pelvis. So if we just go through the bones that you'll need to know, it'll be the skull and the mandible are two bones to know in the head. You'll need to know the breakdown of the spine. You'll need to know the breakdown of the ribs. We will cover all of these and we'll practice all of these in the tutorial sessions. It's more of a working through process to learn these bones and staying on top of it every day. The appendicular skeleton is the skeleton of your body's appendages. Appendages is another word for your limbs. So all of the bones of the arms and the girdles that attach your arms to your skeleton or your axial skeleton, and your legs, plus the bones that attach your legs to your axial skeleton, so your pelvis. And then these are all the bones that you'll need to know. Use these slides on the lecture material to create a checklist for the bones that you'll need to know in terms of the exam. Depending on what field of expertise you want to move down, you may need to know this stuff in more detail down the track. For example, Our massage students are going to need to know this stuff in a bit more detail potentially than our health students, who may actually need to know a bit more about bone remodeling, repair, and our sports students are going to need to know stuff about how the skeleton moves a bit more. So different areas will require different level of knowledge. These are the terms that I need you to remember for this paper. So if we look briefly, we'll touch on this in the tutorials. You'll need to know the clavicle across the front, the scapula. Those two bones come together to create a girdle called the shoulder girdle for your humerus, your radius and your ulnar in the forearm. Your pelvis is what attaches your legs to your spine or to your axial skeleton. So you'll need to know you can remember the pelvis as a whole, not so much these three broken down pieces, but it is three fused bones together. The ilium is the big wing space, the pubis is at the front, and the ischium is your sit bones. Our legs, so we've got our femur, down the front we have our tibia, and at the back you have our fibula. If you look at the hands, you'll need to know small bones of the carpals, the metacarpals and phalanges. If we look at the feet, what's nice is they're the same. You've got your small bones of the tarsals, the metatarsals, and the phalanges. And here's a bit of a diagram of a full skeleton labeled for you to use as a reference to practice remembering these bones. All right, the anatomical position is a reference position that gives meaning to directional terms used to describe the body's parts and its regions. It becomes really important if you are discussing like location of injury or describing how a movement works or position of the body. It gives you a reference point to limit any ambiguity or confusion, especially if you're reading like medical notes or something. The anterior aspect of the forearm and the posterior aspect of the forearm is two different positions. The anatomical position is you standing up tall with your arms at your sides and your palms facing forward. So just like this skeleton model we have here is an example of the anatomical position. Anatomical directions help us describe movements or locations on the body, and think of them as always being pairs. It's a bit like left and right, up and down. For one directional term, there will be the opposite version of it. So we will need to remember these. So we've got superior, which is high or towards the head, and we have inferior, which is the opposite, which is towards the feet. Anterior is towards the front. Posterior describes towards the back. I often think of posterior sounds like posture. When my mum always used to tell me fix my posture, I had to pull my shoulders back. So I think posterior means back. Anterior is the opposite. Medial sounds like middle, so it's towards the midline of the body. Lateral is away from the midline. Proximal means towards the point of rotation. So if we look at the arm, proximal is towards the shoulder, whereas distal is further away. And proximal and distal describes position on your limbs, so your arms and your legs. And we've got superficial. If you think about someone who is superficial, you'll say that they are only face deep, or they only show their emotions on their face or out front, as opposed to being deep or a bit more internal. So superficial means towards the body, surface of the body, whereas deep means away from the surface. So your internal organs, like your digestive organs, are deep compared to your skin. Here's some examples of describing movement. So if we talk about describing movements of articulating bones or joints, we have flexion and extension, which is when the angle of the joint gets smaller. So if we look at my arm, flexion is there, angle gets smaller, extension is the opposite, extend. Hyperflexion and hyperextension is if you were able to go past or extend past. So not always can we hyperextend or hyperflex. Sometimes that might just describe a joint action that will actually cause injury. So if you hyperextend your knee, that generally increases risk of injury. Examples of flexion, extension in the neck. Flexion, the angle is getting smaller. Extension, back to neutral, and then you can hyperextend your head. We've got some rotation-based stuff. So rotation is moving around the longitudinal axis of a bone, so we can rotate our heads, we can rotate our arms, and you can also do that with your legs. Abduction and adduction is describing moving a limb closer or further away from your body. So you've got adduction, which is spelled ADD, meaning adding a limb to the body, whereas abduction is the opposite. So moving your arm away from your body would be an example of abduction. Circumduction is a special type of rotation which describes a fixed point followed by a big circle at the distal end. So the proximal end is pretty fixed, point of rotation, whereas the distal end moves in a big circle. So think of stirring the pot for circumduction. We have inversion and eversion, which is specific kind of joint action for the ankle. Inversion is turning the ankle in, eversion is turning it out. And then we have the same kind of movement in the forearm, except it's called supination and pronation. So pronation is turning your palm down, so I'm pronating. Supination is turning my hand open. I think of supination as like a bowl of soup. To hold a bowl of soup, I need to supinate my wrist or my forearm, and then pronation is that way. Special type of joint action for the forearms. Another special type of joint action at the ankle, plantar flexion. So planting your foot down is plantar flexion, like planting your foot on the accelerator, or dorsiflexion is bringing your ankle up, like a dorsal fin on a dolphin. Alright, so let's move on to the skeletal system sidekick, which is the muscular system. These two function together. Without each other, the other couldn't do what they need to do. So you're going to describe similarities and differences in the structure and function of 3 different types of muscle tissue, define what the muscular system is, and explain the role of the following: endomysium, perimysium, epimysium, and tendons. So that's to describe structure of the muscular system. So our muscles are responsible for body movements, stabilizing joints and generating heat. Muscles generate the force required to cause movement by contracting, so they come together and shorten, a process in which proteins inside the muscle fibers overlap. The more they overlap, the more contraction you get. In addition to the whole body movements, muscles are also needed to move substances within our body. So think things like air in and out of our lungs, food through our digestive system, and blood through our heart and blood vessels. So not just physical movement that we can see, but a lot of some of the movement that happens within our bodies. You can break these down into these 4 functions: producing movement, maintaining posture, stabilizing joints, and generating heat. So we've got 3 different types of muscle tissue: smooth muscle, cardiac muscle, skeletal muscle. Smooth muscle is under involuntary control, meaning you don't consciously decide to contract your digestive system to move food through that system. It's the muscles that are found within the digestive tunnels so that they can contract and squeeze food through. The cardiac muscle is specifically found in your heart. It's shaped in a specific way to allow the heart to contract the way it does. Also under involuntary control, which is great. I wouldn't want to have to worry about consciously thinking about my heart contracting. So you have pacemakers within your heart that help keep that rhythm. And then you have your skeletal muscle, which is the muscle that we know most about because it creates movement. It's under voluntary control. You choose when you want to contract it. Things like your biceps brachii, flexing your arm. In the tutorial, we'll have a look at a demonstration of how a skeletal muscle is constructed. But if we go from the deepest aspect of that muscle to most superficial, so we're going to go deep to outside, starts off with a muscle fiber, which I think looks like I think of it as looking like one of those licorice sticks. That is surrounded by connective tissue called endomysium. Endo meaning in or deepest, that's how I remember it. Then we have a stack of these muscle fibers that are wrapped in another type of connective tissue called perimysium. That creates a fascicle, and then when we have these fascicles together, the whole muscle is wrapped in epimysium, and that creates our full muscle belly. And that connective tissue, which runs throughout the whole muscle, comes together at the ends of the muscles to create our tendons. These tendons then embed into that outside layer of skeletal bone, which is called the periosteum. So the body is fully intertwined with this connective tissue. It's also the same stuff that makes up our ligaments. So it's another thing to remember is tendons connect muscle to bone, whereas ligaments connect bone to bone. If we look at skeletal muscle activity, there are some golden rules that you always follow. So with a few exceptions, all skeletal muscles will cross at least one joint. If the muscle doesn't cross a joint, then it can't create movement. Typically, the bulk of the skeletal muscle lies proximal to the joint crossed, meaning if we look at the elbow, the flexors of the elbow lie proximal or closer to the shoulder for creating movement at that joint. All skeletal muscles have at least two attachment sites. So you'll have one end that attaches to a bone, and you'll have another attachment site that has to attach to something else. Think about how the bicep might function if it was attached to the top of the humerus and the bottom of the humerus, so the same bone. How could it create movement if it didn't cross at least one joint? Number 4 is skeletal muscles only ever pull, so they only ever contract and pull a joint. They never push away, which means muscles work in partnership. You have a contracting muscle, and you'll also have a lengthening muscle somewhere else. And during contraction of a skeletal muscle, the insertion, or the area where the muscle inserts, so biceps, let's say it's on our radius, that insertion, when the muscle contracts, will move towards the origin. And for the bicep, that origin is the humerus and the scapula. So the origin, the insertion, moves towards the origin. We've got types of muscles that we can describe based on their contribution to force production during a movement. So a prime mover is the muscle that is primarily responsible for creating a movement. Chest press or push-up, chest, pectoralis major. An antagonist is the opposite, so it's the reverse of a prime mover. So the opposite of your pectoralis major would be, say, your latissimus dorsi, which pulls the humerus back in the opposite movement. And a synergist, think of that as a helping muscle, so it helps the prime mover do its thing. Go back to the push-up. You've got your pec major, which is pulling your humerus in, but you've also got your triceps, which are helping extend the elbow as you do a push-up. And then a fixator is another word for a stabilizer. It helps keep the origin of the prime mover stable. So during a push-up, for example, you'll have a whole lot of muscles that are keeping your shoulder girdle stable so that you don't lose force anywhere else. You've also got your core musculature keeping your spine in a nice neutral position. If those stabilizers weren't functioning, your spine would collapse, your shoulder girdle would collapse, and it would make trying to do a push-up a lot harder. We can also describe how muscles contract based on the force they're producing and what's happening to the shape of that muscle. So a concentric contraction is when force is being produced and the muscle is shortening. An eccentric contraction is when force is being produced and the muscle is lengthening, getting longer. So a good example of eccentric contractions is holding onto something really heavy and letting it down slowly. So you're creating force, but you're slowly releasing or lengthening the muscle to control that movement. And then an isometric contraction is when force is being produced, but there's no change in muscle length. Iso meaning the same. So holding a plank or in a prone hold is a really good example that most of us have experienced, where contractions are happening to keep everything stable, but there's no actual movement happening, but force is being produced. Okay, so on top of knowing the skeleton, you will need to learn major muscles of the body. So if we look, I've split it into two parts, upper body, lower body. There's 10 muscles that you'll need to know on the skeleton for the upper body, and we'll look at practicing these in the tutorials. This is a presentation that we'll bring up in the tutorial slots as well. There's some muscles on here that you won't need to know, so use again the list in the PowerPoint to break down what it is you do need to remember, and your Quizlets are a really good space for practicing remembering these muscles. Okay, we'll practice this stuff in the tutorials. Lower body, you will need to know the different muscles that make up the quadriceps group and the hamstrings group. Quad is 4, so quadriceps meaning 4, hamstrings is only 3. And again, a whole lot of diagrams. With more info than you need, use the slide on the previous slide to break down what it is exactly that you need, highlight those ones, practice those ones. But most of you will be interested in extending your knowledge of muscles of the body. So again, we'll practice these in the tutorials. And here's a full diagram of labeled muscles, anterior view, so the front view. This is an anterior view. This model is in the anatomical position. And the posterior view, so from the back. This model is in the anatomical position. Unreal. So again, don't panic. It's more info each week. Trust the process. Use those Quizlets, especially for learning bones and muscles. And don't forget that you have an online quiz that closes this Friday for last week's stuff. And then at the same time, this week's quiz on skeletal muscular system will open up and close next week. Awesome. Ka pai.